Hello, I just wanted to do a rundown on how to do each one of these problems for the sample that you had last night. You can read as well as I can, so I'm going to try to hit some of the highlights. Things like number 1A, the probability of a red card or a 7. It is very possible to get both a red and a 7, the 7 of hearts or the 7 of diamonds. So therefore, we have to add the individual probabilities and then subtract the overlap, as we said. So probability of red plus probability of sevens minus the probability of you getting that 7 of hearts or 7 of diamonds. Those 2 out of 52 cards are overlap. And you end up with the 7/13 reduced. A black queen is just that. Queen of spades, queen of clubs, there's only 2 in the deck, 2 out of 52, reduce the fraction. If there are 12 face cards, jack, queen, king, 1 of each suit, that's 12, then there must be 40 non-face cards, 40 out of 52, reduce the fraction or 3-digit decimal. The word and in part D says a diamond and a 5. They might as well just say, what's the probability of pulling the 5 of diamonds? That's 1 card out of 52. So, number 2, the online courses business, that's 2 out of 7, 2 in 7 students enrolled in higher education. You're going to choose 5 people. If each one of them has a 2 in 7 probability, that's 2/7 for one person, 2/7 for 2 people, and so on. You want all 5. You're talking to the 5th power, 2/7 times itself, 5 times in a row. Now, if 2 in 7 answered that with a yes, I took online, then 5 out of 7, 5 in 7 said no, they did not take one. So what's the chances of asking 5 people and that none of them took it? 5 out of 7, or 5 in 7 to the 5th power. Don't know where that came from. It's gone. Then the one that says at least 1 would be the idea of 1 minus none. 1 minus the probability of none. Well, we just did none. The none is the 1/86. Okay? So subtract 1 minus the 0.186, and you get your answer, 0.814. That's number 2. Let's keep trucking. This is a slightly different problem than what we've seen on any of the other samples or even the exam. This one talks about letters on a license plate, and we're saying, well, we're going to absolutely use the first 4 as letters only. That's 26 letters in the alphabet. And the last 3 are going to be only digits, 0 through 9. That is 10 different digits you could choose. If I'm allowed to have repetition, like XY, 443, I can have repetition. Then I have 26 ways of choosing each of the first 4, 26 times 26 times 26 times 26, or you could shorten that to 26 to the 4th power. And then you have 10 times 10 times 10 for the 3 digits, 10 to the 3rd power. Okay? And then the calculator gives you the big 456 million number. If you're not allowed, there's 2 ways you could play with this. You could say, hey, I could have 26 ways of choosing the first letter, 25 ways of choosing the second letter, because I can't repeat, 24 ways of choosing the 3rd letter, 23 ways of choosing the 4th letter. Then when I go to choose my numbers, I have 10 ways of choosing the first digit, then 9, then 8. If you multiply all that together, there's the answer you get, 258 million. I said there were 2 ways. The other way is to realize that I am basically saying, hey, I have these 4 and I can't repeat them, so it's permutations. How many ways can I permutate the 26 letters 4 at a time? And 10 permutating 3 at a time. Both of those will give you the exact same answer. So it's up to you how you look at that. Last but not least on this section, if they let me repeat the letters, that 26 to the fourth came directly from this 26 to the fourth because I'm allowed to repeat letters. The 10p3, the way I did it, comes directly from the 10p3 or the 1098, however you want to do that, because I'm not allowed to repeat digits. And then you run the calculator. People did very, very well with this one. Pittsburgh has 10 letters in it. The only pair that you see as repetitious that I see there are the T's, so it's 2 factorial on the denominator. 10 factorial divided by 2 factorial. For the word assessment, I have 4 S's. I have 2 E's. So it's still the 10 factorial on top, that's our total letters, divided by 4 factorial, 2 factorial. And as far as this whole question of how many more business, it's just me saying, I'm not going to ask that, but you're saying, hey, this is 75,600. To get to 1.8 million, you'd have to multiply it by 12, which makes sense because 4 factorial is 4 times 3 times 2. Oh, hold the phone. 4 times 3, that's 24. I knew I did this too quickly. So I apologize, but this part is all I really am looking at doing or getting on the exam, so be careful. Next, let's see. The sorority. So this is the juniors, sophomores, and seniors. If they say they want 1 of each, then yeah, with the 7 choose 1, 8 choose 1, 5 choose 1. And 7 plus 8 plus 5 is 20. 1 plus 1 plus 1 is 3. So it's divided by 20, choose 3. I have to divide by the total because this does ask for probability. Be careful. It's not how many ways, it's how many ways can this happen divided by the total number of ways. The totals, okay, so that's probability. And then reduce your fraction or just make it into a 3-digit decimal and you're out of there. The one with football team, seniors, sophomores, juniors, freshmen. The biggest thing I will tell you is that if this problem is talking about seniors or anything that's talking about seniors, it says we only have 5 seniors. Well, there's 45 people up there, 15, 15, 10, and 5. If there's 5 seniors, then there's 40 that are not seniors. Okay, keep that in mind. Part A, I want 5 seniors, I'm choosing 4. That means that the other 40 up here, I'm choosing none. Okay, whether you write that down or not, that's up to you, but it does allow you to make sure you've accounted for everybody. Notice that does come out to be scientific notation, 3.356 times 10 to the negative 5th. Move your decimal 5 places to the left and round off to the nearest 3 digits. Because there are more than 3 zeros, you go to the very first non-zero value and round it off. This is 3, so that would be just 0.0003. All right, 1 of each. That's why I have 1 of each here. Again, throw that through the calculator. 15 choose 1. Anything choose 1 is anything. So 15 times 15 times 10 times 5. Divided by 45, choosing 4 people. I get 0.076, and you're done. The third one, 2 of the freshmen and 2 of the sophomores. None from the juniors or none from the seniors, and the same answer, similar answer, 0.74. And then the big dog here, letter D, at least 1. At least 1 means 1 minus probability of none. Okay, none being a senior. So I don't want any seniors. That's 5, choose 0, and I will choose 4 from the other 40. When you do this, you get 0.613. 1 subtract that is 0.387, and we're good to go. So that's the probability of at least one of them being a senior. Okay, keep on going. These last ones go pretty quickly. If I can get this right. This is the one that says the phrase given. So we need the both, the probability that both occur, that's the and, 13/78, divided by the probability of the given part, which is the 5/12. So you do your division, let the calculator cook, you got 0.400 or 2/5, you're done. Number 8, 58 people in the Bloom Fan Club. That's probably about 52 bit too high, but that's okay. 58 people in the Bloom Fan Club. I am specifically looking for a president, vice president, and secretary. 3 people. 58 permutations, P3. You're done. Throw that through the calculator. If it simply read 58 people in the Bloom Fan Club, how many ways could I choose 3 people to bring in snacks tomorrow? Then it wouldn't matter which order I picked you in. In that case, they would be combinations. Okay? You have to just ask yourself, is the order mattering? And in number 8, the way it reads, it does matter. Because if I pick you first, you're going to be president. Okay? John, Sally, and Lisa in different orders. One of them gets to be the president. One of them gets to be the vice president. The order they get chosen matters. So this is a permutation. Okay, I've beaten that horse to death. Let's go. Number 9, car ownership. Owns a car, 0.78. 78% of people own a car. So if I come over here and I say car is 0.78, that's the entire pink. Then it says, well, what about these people in the boat? Well, the boat people, where are you at, boat people? 45%, 0.45. That's the entire green. The problem is we have this whole area in the middle that is an overlap. Okay? They're not mutually exclusive, which means we've got to add the 78, add the 45, and subtract this overlap. Okay, we can't count that twice. So you end up subtracting the 0.26 that's in here. And you can see as well as I can, that comes out to 0.97. You're done. I hope this helps. I hope everybody's ready for this test tomorrow, the retest. If you have any questions, let me know. Thanks.